Okay, so guess it has started now. So we could start. But before I start my presentation, I think it would be very helpful if everyone connected could probably just say a hi or a hello at the chat, so I get to know that everyone is with me here. So maybe I've started. Hello. Maybe just type, say something, your name, anything. Okay. Brian, Abubakar, Glory. Okay. Oluwasenga. All right. So yeah, I'm not alone, so that is fine. Okay, so I think I already introduced myself the last time that I met you all with Yabel. So I'll just reintroduce myself, just for those who probably were not on the call. So my name is Deborah. Dormah, and I'm Ghanaian and actually currently in Ghana as well. So I'm with the African Masters in Machine Intelligence program at AIMS Ghana. Um, but before then, I completed my master's degree with the African Institute for Mathematical Science in Senegal as well. So for anyone who probably is interested in knowing more about the AMI program and the centers and how to get admitted, I would be very happy to help with regards to that. So for today's tutorial, I'm going to try to be very brief. So the idea is just I prepared the starter notebook on the challenge on bank term deposits. So I'll just want us to just go over the notebook together and then see if you all have some questions or you need some clarifications. Then I could offer some advices with regards to that. So I'll just share my screen here. Okay, so the challenge was the bank institution term deposit predictive model. But then, if you have any questions as I'm presenting, please don't hesitate to leave it at the chat. Just leave your questions there, or you can just unmute yourself and then ask your questions. So the idea of the challenge was that you finished up an interview process with the Bank of Portugal as a machine learning researcher. And then the bank actually has this problem of identifying their customers who will subscribe to their term deposits. So basically, term deposits are it's a type of investment where customers can actually keep their money with the bank, like invest their money with the bank, and then later get in some interest out of the money they're keeping with the bank. So the bank too would use that money to do other external investments. So usually it's very important if banks are able to identify which of their customers will subscribe to those term deposits, because before they get convince customers to subscribe to term deposits, that will mean that they have to do several calling and maybe meetups and all of that. So they don't want to waste their resources. And at the end, these customers don't subscribe to their term deposits, right? So this data set, I got this from UCL machine learning website. So when on that website, you have different CSV files, but we'll be working with just one. But I will encourage you that later on, when you have time or in your spare time, you could try to play around with the other CSV files. So the one we are working with in particular is the bank additional CSV with all the examples, right? So for that particular data set, we have about 21 features with one target. So I assume that, probably we've had time to go through these attributes to understand what they mean. So I would just want us to start with the notebook that I just prepared. So for this notebook, to begin, we have to load the data set. The packages that we need. So For the meantime, we had pandas for manipulating data frames and NumPy for manipulating arrays, Seaborn and Matplot for our plotting and stuff, and then the standard scaler from scaling, right? So the first step is to load the data set. So I realized from Slack that some of you asked questions with regards to that. You loaded the data set and initially it was giving you something like this. So that was because you didn't add this separator. So usually when you're saving CSV files, you usually would have them either saved with a separator, maybe it's semicolon, it could be a comma. So if you look at the original one, you can see the semicolon here, and that's why we had to include the separator as a semicolon. So yeah, so once you add that, then you can load your data set pretty well. So we have here just a head of the data set. And then the next thing I proposed we did was to check our target. Our target was called Y, which is whether they will subscribe to term deposits or not. So for that particular target, we realized that we had those who subscribed to be about 4,640. And then those who did not subscribe to be about 36,548. So that's like quite a huge difference between those who actually subscribe and those who did not. And the interest of this bank is to be able to identify these people in particular, those who would subscribe, this small number. So the next thing that we had to, when you're dealing with any machine learning algorithm, is to at least know your data, right? So from this, we realized that our data set has this number of rows, 41,000 rows, and then 21 features, or more or less the column. Then you also want to know more information about each of the data column, and then know what type they are. So like age is an integer, job is an object. This is actually very important because if you don't know the type you're working with, there are some of the columns that probably you can have marital being saved as a float. So you would have to make those changes, else they would actually have an effect on your final model. So it's usually very important that you try to check what data type you're actually dealing with. The next thing you want to know is whether you actually have missing values in your data set or not. So fortunately for us, we don't have any missing value in our data sets. And then the next thing we also want to check is using the function of describe, which gives us information on the mean, the descriptive, like the mean, the standard deviation, and the first quartile, second quartile, the median, which is a 50%, the maximum value, the minimum value of only the numerical columns. So what I did here was to select the data types that were actually numerical, right? So here we can get the information that, okay, the mean age here is 40. So at least you know that averagely the age of people is 40, right? And then you can also know, okay, what the maximum age here is 98, and then the minimum age here is 17. So these are things that just helps you understand your data pretty well, and it's usually important you carry them out. So as part of your task, I mentioned that I wanted you to do some univariate analysis. So univariate analysis is just doing analysis for like single features, just one column. You try to understand what is in the data, like counts or whatever you have to check for it. So here I just wrote a simple function for plotting a cat plot. So more like a bar plot, right? But using Seaborn here. So the target, first of all, we checked here. And then, yeah, we already realized that, yes, we had very few number of yeses and then quite a number of no's. So the question here I asked is that this is a class imbalance problem. A class imbalance problem is that we have more of the a particular class having more members or rows than the other class. So can we just like probably maybe if you have an idea or suggestion, how do you think that this class imbalance problem can actually impact your model performance. Anyone with an idea, if you want to say something, just unmute yourself. I want this to get very interactive. So bias, okay. Bias in what sense? Like bias to the class that has more number of features. Stefan, model will mostly predict class 0. Okay, that's because it has more members, right? Because it would learn that particular class. So like in our case, the model is going to learn like those who actually don't subscribe to term deposits. That's those who have no. And then the yes, that's what we are actually interested in. The model will not always be able to identify those who would subscribe because we have very few number of cases for that. So that's right. All your answers are right. Yeah. So it could introduce some sort of bias and the model predicts class 0. Okay. Yeah. So then the other is that, so what are the data techniques or approaches that could be useful in this kind of problem? What do you people think? Like what could actually, can you use to address this sort of problem? Do you have any ideas or have you read anything with? Okay, smooth oversampling, yeah. Oversample minority class, yeah. So this is one of the tasks you're supposed to do. So there's a very interesting blog on this, on smooth, and smooth basically still oversampling the minority class. So you could try to see how it's done. So what it happens with smooth is that it's, first of all, let's say you have two classes, right? So for the two classes, if one class, let's say a class, in our case class no, it's that 0, it's having more of more of the people who actually did not subscribe. Okay, can I share okay, I will do that. Okay, so what will happen is that the class that have very few samples, it will just sort of create like, what I call it, it's, you're putting it is in the same data space, but then it just sort of extends it. So it could be a linear line that it could extend and then create extra features to add up to that class that has like very few number of cases, so that at least you can have more cases and then your model wouldn't be biased. Yes, so I'll try to share this link with you. I think I saw it somewhere. I'll just look for the link and then share with you guys as well. So smooth is a very good example. So for your case, you could try to use smooth to handle this. So like the next column was on marital. So this I just tried on a few of the categorical to plot them. And so for the marital, we have married as having more of the count, and then those who said unknown, probably they don't know their status, whether they are married, they are single, they are divorced, any of it. So they form unknown, but they are very, very few. And then we also wanted to look at the education as well. So all of these things are just to help you think. So here you could observe that you have like quite a number of levels for education. For instance, you have university degree, high school, basic, professional course, and all of that. So one technique you can always do is that when you can, first of all, build your model with everything. But if you want to improve your performance, you could come back to try to regroup some of these levels. So for instance, this basic and then high school, you could group them together to form one class, one level. And even so you could group basic 4Y, basic 9Y, basic 6 as one, as basic or something. Then unknown, illiterate, you can put all of them as unknown. So just to try to reduce the levels. So you can have about 4 or 3. I think one other, yeah, you can have about 3 or 4 that you can work with so that you don't have too many classes. Yeah, so we did that for the job as well. And then for the age distribution, for the reason why we have majority of them between those ages. Anyone with an idea? Okay, so I think that this is a bank, right? And then if the ages of majority of them are between 25 to 55, we can understand it from the angle that for instance, in Ghana, for my country, for instance, you can open a bank account when you're 18, like you're by yourself, right? But then if you're below 18, you need a parent or a guardian who can help you open the account. So in this case, most of those people who would be thinking about investing or are in the working class ages are between like 25, 55. By 60, you're going on retirement, which I know happens for most, working class for most countries. So we can understand that this is why the ages is taking that angle. So the next thing you were to do was to think about some bivariate analysis. So bivariate are comparing like two different columns. So we did a bivariate to try to understand using box plots. So with a box plot, you can interpret by looking at, that this is your median age, this is your quartile 1, then quartile 2, which is the same as the median, and then the quartile 3. Then you can identify your outliers in your data and compare them to the targets, with whether they are actually whether the person subscribe or not. So those who did not subscribe are the blue, and those who subscribe are the yellow. So you can compare that, okay, the mean actually is a bit higher than those who did not subscribe. So this is just to help you understand your data, try to see what is happening in here. So we did that for some other different columns, and then also to check our correlation as well. So of course, the correlation too is important to know, because we don't want a case where we have the two independent columns being highly correlated. So we want to do away with those ones as well. So you have to do this correlation to be able to like check for all of those things. Okay, then now this part, the data preprocessing. So what I did for the starter notebook was to use label encoder, but for your work, I'm suggesting you use one hot encoding. So what label encoding just does is that it gives numeric, like for instance, if we pick the educational level of people, we had primary, university, basic 6. So what label encoding does is that it simply just gives a number. Okay, 1 is for tertiary, 2 is for basic, 6Y, basic 4Y is 3. It just gives those numbers randomly. And normally this is not very effective, or it's not a very good way to do the label encoding. Can anyone explain why this actually would not be a good idea? Label encoding will not be a good idea when to use as an encoding technique. Anyone with an idea? Hierarchy issue. Okay, yeah. So normally if you do that, if you say that university is 1, basic 6Y is 2, what it does is that, I mean, numerically 2 is bigger than 1. So it's more like you're taking that, okay, the basic 6Y is bigger or has some sort of more advantage, or it's more advantageous than the those in the universities, but that is not the case, and unnecessary weights would be added. Yeah, and normally if you just do it this way too, if you are building a predictive model, you have a weight. So what you're saying is that if it takes, let's say it gives a weight to education as, let's say 25, it just takes 25 someone's education and multiply by, that's the coefficient, and multiply by your education, maybe high school or university. It works with it directly like that, which is not helpful. So I would suggest that you try to use one hot encoding, which would do them as ones and zeros. So if the that particular column, you have that variable, like that, if you are dealing with one person and then the person actually has university education, you have 1 for it and the rest will be zeros. So it's like you use those separate university, you use basic 6Y, you use basic 4Y, all of that, and create independent columns. And then for each person, if the person's education is university, you put 1 and the rest of them would be zeros. So you're going to have like a very big matrix. Yes, you have a question, please feel free to ask your question. Ilgura. Yeah.
Okay.
Good
Good afternoon.
afternoon.
Good afternoon. Yeah. Basically, one encoder basically increases the data set, right? So when do you advise someone uses label encoder over one encoder? Because let's say, for instance, you have a lot of variables in a particular column, and you are using one encoder. That means the data set will be very big and it will be cumbersome. So what is your advice? Like, when should we consider using label encoder, and when should we consider using one encoder, so that we won't really have a lot of cumbersome data sets? Thank you.
Okay. All right. So like normally, I would say that if you are beginning, like you're working with something and you know that you don't really mind that this is bigger than this, like you don't have that, what's the right term I should even use for this? You don't have like any like, for instance, let's say you pick color, right? You know color blue is not bigger than red or anything. So certainly in those cases you can just go ahead and then use your one hot encoder, because you know that blue is not bigger or better than green in any way. But for instance, let's say you're looking at performance of people. So you have someone being like, okay, excellent, someone good, someone medium. So of course, in those circumstances, using label encoder would make sense, because if you say that excellent is 3, good is 2, and then bad is 1, certainly you can think about it in that direction, because you know that yeah, excellent is way better than good and good is also better than bad. So in those kind of categorical columns, you can make use of label encoder. But then if you're dealing with columns where like colors, like educational level, which I wouldn't also see it. Okay, educational level too, you could also think about using label encoder as well. But you're looking at like I mentioned, color, you maybe place, countries. No country is better than the other in that regard. So one hot encoding should do. When you say,
Okay,
sorry,
thank you very
have
much.
I answered your question? Yeah.
Yes, yes, yes.
Okay. Um, Rafia, you said when you say little groups, I don't understand your question. And then Gloria, you say, is it just me that imagines this guy asking question with a microphone because of his picture? Okay. All right. So I guess if there are no questions, can I continue then? Okay. So all right. So yeah. So in this case, I'm suggesting you use one hot encoder, but it would also be an interesting experiment if you could try to do both, like do the label encoding, do one hot, see how they perform. Or you could select some of the categorical columns, do the label encoding, like education, do the label encoding, but columns like marital and others, you just go ahead and then do one hot and see, and like check the performance. It's just a way to, I mean, experiment new things and then see how they work, right? So this everything I just did label encoding for this. So yeah, so and then for the numerical columns, I decided to use a standard scalar, but they are different type of scalars you could also make use of. Well, I mean, some of these things sometimes would always depend on which works better with your data. So you could try the minimax or the standard scalar itself, which is also good. You can just try any of them and then see which works. So now, at least in our data, we don't have any other category. Everything are numerical, which we can feed into our model now. So in the from the website, the data set itself, we are informed that duration, the last duration in seconds, actually is highly correlated with the our targets. That is to say that if the duration is actually 0, then y is 0 as well. And so you don't want to feed in information like an independent variable as an information when that also sort of informs your target as well. So they advise that this input should only be included for benchmark purposes and should be discarded if the intention is to have a realistic predictive model. So for this case, I decided to drop that duration column, and then of course in the X drop the Y as well, so that we don't have that, right? So now the data set for this notebook was made with test size as 20% and training 80. But for your work, you're supposed to use 90% for training and 10% for testing. So you should take notice of that too as well. So now I built a simple logistic regression, and then got an accuracy of 90%. That's just straight away, right? But when we look at the confusion matrix, for instance, our total correct predictions gives us 7,294, and wrong predictions are 944, sorry. Right. And then if you look at the classification report too, you realize that the people who actually subscribe, actually the F1 score is pretty bad, 33%. And then the F1 score for this is like 94%. And we are actually interested in these people. And unfortunately, our model accuracy is very good, but then you realize when you come to these details, you're unable to actually predict one class very well, which is not a good thing. So sometimes maybe just for you to know in I'll come to your question, Kevin. So just for you to know, sometimes in an interview, they can ask you that accuracy a good measure. So this is a very good example why accuracy is usually not a good measure to tell if your model is good or not. Because, I mean, in our model here, we have 90%. But then in actual details, we realize that some of the, one of the classes not, the model is not learning one of the classes. And that's what we are interested in. So usually accuracy is not good for class imbalance problems. So, I mean, that's an answer you can give in case you are in an interview and they ask you such a question. Yeah, Kevin, you said pandas gets dummies. Yeah, it's something similar to one hot encoder. Is there any reason you can use one instead of the other? I think it works the same way. Actually, for one of my works, I just made use of the dummies one hot encoding. Like you just select the categorical, create the dummies for them, then you merge it to your data and then drop the other columns. So you can use any of them. Okay, so now the other is to check the ROC, which is more like the sensitivity and yeah, the sensitivity. So here for the logistic regression, we got the ROC to be 60%. So usually the more this blue curve is getting closer to this true positive rate, the better your model. But our model isn't very good. So it's just like 60%. So this is really not good. So yeah, this is really not good. And then this was a model for decision tree too as well. So here with a criterion, you can use entropy or Gini. You could try reading about which of them you would want to use. So I just use entropy here. And then we have accuracy of 89%. And then we're able to check which features are actually important. And then also now plot to see how the model actually is working. So here we have the number of employment, how everything was splitted in here. So what we propose that you do or try more is but of course, sorry, let me mention that this I did not also do any hyperparameter tuning. The max that this is like default 3, but of course you can add some other hyperparameters. So you could try using grid search to try to get the right hyperparameters for your model. So for the other ones, like what we're asking you to try, multi-layer, random forest, XGBoost, support vector, I mean, you could try to find good hyperparameters for them. For support vector, the kernels usually are different, linear, poly, and RBF. So you could try the 3 and see which one works better, then you choose. So you were supposed to try all of these models, but eventually you have to pick just 3 and then submit. So this is just to allow you explore different machine learning algorithms, like work with them on a data set. So at least you get to know them. But then of course, you are allowed to choose final 3 and explain why you're choosing those three as well. Yeah. So this is for the notebook part. So I mean, this is just a whole idea as to how to go about your model development and all. The other thing are there any questions first? Okay, so get dummies also does by now is one advantage to use it. Okay, I think Brian is sort of answering Kevin, right? Then Rofia, you said, please, can you go over the confusion matrix and classification again? Yes, I can. So here. Okay, so the confusion matrix, confusion matrix, this is already in sklearn metrics. So we give it the y-test and our predictions. So it will give you like a square matrix. So for this value, it's the ones that are who actually did not subscribe to term deposits. And then your model also predicted, yes, they did not subscribe to term deposits. So these are like it's a correct prediction. Then this is a wrong prediction. Here, we are saying that the model, the actual value is that the person did not subscribe, but our model said it's subscribed. That is actually like false positive. So it's a wrong prediction. Then for this value, we say that the model actually said the person subscribed when actually the person did not subscribe, which is a false negative, is this value. And then for this value is that the model actually, the person actually did not subscribe, and then our model also predicted that the person subscribed. So this is a correct prediction, true positive. So usually the values at this side would add up to give you your correct predictions, and then the ones at this other side, side would add up to give you your wrong predictions, right? So I mean, this side is what we're always interested. We want to get very small values for these wrong predictions, reduce them as much as possible. But we realize that this value, for instance, we are not able to reduce this value, the false negative. So yeah, so I don't know if this is fine now. Rafia, is this okay with you? Okay. All right. So this,
Hello.
yeah.
Hello.
Yeah.
So I have a question. I have like two questions. Okay. The first one is this. When I was studying the data set, I saw a particular column. I think credit. Part of the column is about credit, so I don't really understand that column. Like, if it's default yes or no, maybe the default credit. So I want to understand. Is it like the person is owing the bank, or the person has money in the bank, something like that? The credit part
Credit.
or default?
Okay,
Yeah.
default has credit
Yes,
in
default.
default. Yeah.
Yes.
Yeah.
They are
So
owing the bank, right?
yeah, when you default in credit, like has a person defaulted in credit, yes or no, or they don't even know, they have that information too. So okay, with your question, what we could have actually framed this to be is that we could have actually also used that column as our target, so that we are interested to predict who has defaulted and who hasn't, like a credit default, but then we are using the term deposits rather. So we could have actually made this our target, but this case, this is also part of the independent variables, not dependent. But it actually means like what you said, have the person defaulted or not.
Okay. And also another question on ROC curve. Today I saw a particular curve that is quite straight, very straight, like straight, passing through the origin, as if it's like a linear. That's a linear relationship with the
I'm
first
sorry, you said
positive.
you saw what? You said
I
you,
saw. Hello, can you hear me?
yeah, I can hear you.
Okay, yeah. I said today I saw an ROC curve,
Mm-hmm.
and the curve is kind of like very straight, passes through the origin, and it's kind of linear to the false positive and the true positive. So I don't know how I could have interpreted that kind of curve, and I don't know if you can also go over the ROC curve too. Thank you.
Okay, okay. So you mean here, like in our case, we have the blue, it's like it comes this way, then down to the side, right?
The blue is just as if this red dotted line, just straight, nothing, no other
Ah,
blue
so
line
it's
there.
at the same. Then your model is not
Yes, yes.
learning anything.
No, what do you say?
Then your model is not learning anything because this line is the origin, and so you have like true positive 0, 0, 0, 0, 0, everything, and it's not letting you.
Okay. Please, can you go over this other blue line again? Like, can you just give
Yes,
another
so I'm
explanation?
saying that this blue line right now, the area of they're saying that the area is 60%, right? So now this blue line is what we're interested in. If this blue line is getting very close to where the true positive rates are, then it will increase the area to be above 60%, which would show this is a good model. But the more it gets close to this red line, then this is a bad model. So we are interested to increase the area in here, like between the red line here and then the blue line here. That's what we are interested to increase. So the more this blue line is getting closer to the true positive side, then we would have a way better model. So in your question where you said you saw one that the blue line was just here, then the model actually is not like learning anything, nothing. I don't know if that answers your
Thank you
question.
very much. Yes, yes, very well.
Yeah.
Thank you.
Excuse me. That brings up a question on my side. Should I go on, please?
Yes, please.
What does the area represent truly between the red line and the blue line?
Okay, so I think the area basically is telling you how well. Okay, it's here. So the area here is going to calculate what your model has predicted and then what actually the value is. So you're trying to ensure that you increase that correct prediction in between here. You want to ensure that you're able to increase that area, which would show that you have a very good model. Or I don't understand your question.
Yeah. Like I don't know. I don't know how better to put it though. I just wanted to know what it shows. I guess it just shows how correct the model is. So yeah, that's fine. Thank you.
Okay, please, does it calculate it by rate? I don't know. How does it do? It sums the prediction. How does it do the summing of? That is what I think. I don't understand that.
You mean the ROC?
Yes, the ROC. Exactly.
Okay, so this I use the Python package calculating ROC curve, but then I think there's a formula. There should be a formula for it. So let me get that. So usually it just takes the positive all over the positive plus the negatives. That's how it calculates for it. Hello?
So how does it keep moving? How does it keep moving? I don't understand. I thought it's supposed to give you a particular value or something. I don't know. I don't understand how it's still moving till the end. I don't understand. Is he adding each value and calculating it and then going up? Like, I don't understand.
So for maybe it's a rate, right? So you're looking at different values. So you do this, take the positive, divide by the number of positive you have plus your negative, then it gives you the value, then it calculates for the area for it. So it's a rate, so it's a ratio you're looking at, the ratio of the true positive all over the number of predictions you have. Hello?
And it became a curve. Jesus, that is.
Sorry?
I'm still finding it. Okay, thank you.
So I'm
I
saying
still
that
find it out.
it takes the right values divided by the total number of predictions you have. So okay, Patrick is saying true positive plus true negative divided by this all. What is down is actually the total number of predictions you've made, whether they are wrong or right, everything. So you take the correct ones divided by all the ones you have predicted, then it gives you the rates. So that rate is now represented more like an area, which they plot with the curve.
Thank you very much. Thank you. I don't still understand honestly, but thank you very much.
Okay, no, wait, come again. What exactly don't you understand? Maybe you should be able to like explain exactly what you don't understand. Then in that
Okay.
sense, because I thought you wanted to know how it's calculated for. We've given the formula for that.
Yes. I
And
understand why. I'm what I expect was a value, like a result. Like, for example, the accuracy, we calculated the accuracy and got a result of 0 point something or zero. I don't understand how the value is something that is continuous, not something that will just get one answer. That is my own problem. Like, where is the place that it starts increasing? Like, I don't understand. Does it calculate it like for if you have 100 variables, does it start calculating from total number for the first 100, first 10, then it keeps going like that? That is my question.
Okay. I don't know if anyone else, I probably I still don't get what answer you exactly want. So is there anyone who probably understands and would want to answer or address his question? Maybe understand what he's trying to, what he actually doesn't understand and can explain.
Hello. I'm not answering the question, but I just want to explain what it meant. Like, I believe what he's asking is why is the thing increasing? Like, how did they draw the curve? Like, basically now this curve now looks as if this thing is increasing with time. Like, it's like a seasonality trend, something like that. It's increasing with time. So it's asking if you are calculating it per time, or like maybe per a column, per the x column, or because basically if you calculate this thing, it's also give you a particular line, a particular point. So why is it that this thing is now moving from zero and then moving to the end as if it is moving with respect to the x axis? I think that's what is asking. I think that is just basically his question.
Okay. Okay, so what I get from it based on the formula here too is that you have like this, you give it the y test, you give it this. So I'm looking at it like it's a rate they calculate for, then that rate is expressed as an area. So I'm not looking at it like at every point in time they're calculating for it, because it has to take all your like values, the predictions that you have gotten right, divided by the total number of predictions you've made, which would give you a particular value, which is drawn as like expressed as the area, and then show the curve. I don't look at it like at every point in time. It does everything together. That's why you probably give them like you give it the y test. That's which is going to be like an array, then your prediction. So it will calculate the differences for all of them, which ones are right, which of your predictions are right as compared to the actual predictions. Count them, add that, become your numerator. Your denominator will be how many predictions actually you made. So I'm looking at it that it's just one value, because right now, for instance, if I decide to even do this, the ROC here is 0.6, this, right? Okay, but then here the next curve is that you take the y test, then you take the prediction, the
I'm
probability
understanding
of
it now.
each value
Understanding it now.
of each value.
It's a log function, like it's log. The log of the distance is what is plotted. That's what I'm assuming here now. Because I'm seeing log here. So like the log function is what is plotted.
No.
Like that's
Where are you seeing log?
Log now. You are writing log oh,
Logits. Yeah, logits. Yeah, the logits of the ROC, which is this value, which is 60. Here we have, right? Then now the plot is saving as it takes the y test, then predicts each value, save that as the false positive. Sorry, your predicted, and then this is the true positive. So like this is going to give you like the prediction, the ROC curve will give you three different values. One would save in here, the other will save in here, and these are the ones we use to plot the curve, because we are plotting with this and that plus the label, and then we add our logits accuracy there.
Hello.
Yeah.
Okay. Okay. Hello.
Yeah.
Okay. I think if I understand what you have just said, so basically, this ROC curve now, we check for the y test and then check for the predicted value or the predict proper for the x test for each value, right?
So first of all, the score is the formula we have given. It would first of all calculate for that formula using your whole the whole array that you have. So your y test is like made up of different numbers, like it's an array, right? Then your prediction too is going to be the same length with this y test, which is also going to be an array. So it uses these values that it has, calculate for the value of the ROC itself. So this is the value of the ROC itself. Then to get the curve, we take the value of our y test, predict this x test based on, like, you take each value, But then for each value, whatever you get, you put it in the false. Like you put one, it gives you 3 different values. So you have the false positive, the true positive rate, then a threshold. So it's based on this two that we use to plot the curve.
Yeah, I think it's clear.
Okay, so Patrick has added something. He says an ROC curve shows the relationship between clinical sensitivity and specificity for every possible cutoff. The ROC curve is a graph with the x-axis showing 1 minus specificity, which is equals to false positive fraction, which is equal to false positive all over the false positive plus true negative. The y-axis showing sensitivity, which is equal to the true positive fraction all over the true positive plus the false negative. Thus, every point on the ROC curve represents a chosen cutoff, even though you cannot see this cutoff. What you can see is the true positive fraction and the false positive that you would get. I don't know, I guess maybe you want to write when used or something, right?
Okay, please, can you just show me the values for the TPR and the FPR? Let me just see what it is
The
like,
values
so I
for
maybe understand them too.
the values for
The TPR and FPR, like you guys what you plotted for, I don't know.
Okay, so this is like 0, 0. The FPR is 0, 0, 0, blah, 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 0.99, 0.99. Then the TPR too is like 0 point this. So like they all have different values. I can comment this out then. Can you see them?
Yes, I can. So, like, I don't know, sir. Oh, yes, I can.
Hello? Are you with us? Can you
Hello?
yeah, can you see?
Yes, what was plotted was our TPR and our FPR now. That's what I'm seeing here clearly now.
Yeah,
Abi, is that not what was plotted?
these are the values, right? You asked that
So
I
these are
printed.
what we got. Hello?
Yeah, I'm with you.
This the ROC curve, these things that we saw now is what we plotted now, right? And what we plotted.
Yes, these are what we've used to plot now.
Oh. Like this is a new idea now, a new idea from now. Wow. I
Wait,
understand. Thank you very much.
okay, but the first thing you should know is that the ROC curve is calculated as one single value, which I initially printed. This is calculated as one
Yes, I
initial
understand
value.
that. Yes, I
But
understand.
yeah, it's calculated as one value, right? The ROC. But then to
Okay.
plot, you use the false positive and then the true positive, which are these values that we have here now.
Oh, that was the question I was asking. Thank you very much. Thank you. I understand it now. Thank you.
Okay. This is okay. We can read more from the link. Okay, so Patrick has put a link there. He's suggesting if you want more information, you could also read more about it from the ROC curve. So if there are no other questions, I just wanted to do you guys have any issue with regards to how you're supposed to split the like the for the GitHub, how you should split the tree, know that okay, what is going into main, what is going into model, and all of that? Or shall I just touch on it briefly because we've already spent an hour? It's just 3 minutes to time.
Please touch on it. Anything that will help us.
Okay. So here basically, I guess probably we are all conversant using Visual Studio. You could usually it's good using a text editor, but then of course you can also do it on Anaconda if that's what you're comfortable with. So we asked first of all that you should do in your data, how you load your data, your main, then the model. So what would happen is that you're going to have the main notebook itself. That's what I just showed to you with my starter notebook. You have everything inside, but then you create a different .py file inside the same the same folder. So you create a .py file, call everything that you need regards to loading your data, and then write a function like a data loader function in it that would like get your x and then your y and then return your x train and y train and x test and then y test. Then you have a model.py. So here I just put only the decision tree, but then you of course you can create another function that will have like all your models that you use. So you can have like the logistic, you can have, I don't know, maybe your multi-layer perceptron or anything, depending on which ones you are using. So you can have all of them in one. So whatever package you use for your model, you should ensure that you load it in there. Then you have a main Python file where you call all of these things. So, I mean, if I call like the model.py now, I can call it from the main file here from model import decision tree so that it can import this decision tree that I used in here. Then you can go ahead and load your data with pandas. Then you get your X train, Y train from your data loader here. That's why we asked it to return X train, Y train. Then you can call, I mean, the different functions that you have. So here I just used decision tree. So it was just decision tree. Then you can have logistic regression and all other models that you use. So you do all of this in one particular folder. With regards to getting the requirement.txt file, you could just open your terminal on that particular folder and then do pip freeze. Then you name it as requirement.txt. Then it should do this for you. But some others advise that you should try to create a virtual environment in that same pace so that it doesn't like sort of get unnecessary packages that you did not actually even use for the work, because that's what I did here. It's not all of these things that I use, but because I didn't create a virtual environment, it sort of gives you all the packages and things that you have installed on my system. So, but if you don't need all of these things, you just create a virtual environment, then you do the text file. I don't know if there are any questions. Mustafa, you say
Hello.
yes. You will get it maybe. Yes.
Yeah, I have
Okay.
a question.
Okay. One.
Hello. Can we use Google Colab for this stuff? Because like I mostly use Google Colab for my data science work. I don't know. Is it possible?
Colab to do all of this. I've not tried it on Colab, but it should be possible to do this on Colab as well. But I don't know, maybe you have to check on how you can create the requirements text file to on Colab. There should be a way. I've never tried it, so I can't speak so much about this. Patrick, you want them to touch on decision trees? Okay, I'm coming. Yeah, so any other question with regards to,
Okay,
how
please. This is not. This is about TNSC. Hello.
Yeah, I'm with you.
Okay, you talked in the project there was something about TNSC. I don't know if you can say something about
Tisney.
and I don't know exactly what
Tisney,
it is
yeah.
exactly.
Okay. So
Yes.
it's also more like what do they call it? PCA. So it's a dimensionality reduction technique. So you probably have to read more about it, because I'm not supposed to give you all the information, right? So you could try to read more about, but it's just basically a dimensionality reduction technique that you can explore to see how you can extract the features that are like more important with regards to this problem.
Okay, thank you.
I don't know if you're familiar with PCA.
I'm not familiar with any of them. But we have worked with it before, but
You've worked with
I
PCA.
can't say. Yeah.
Okay. Yeah, so it's basically a dimensionality reduction technique too as well. So
Okay, just give us pointers to the right direction in a way, at least. I know
Okay.
sklearn has a library for Tisney, I mean, to do something like that.
Just a second. Yeah, sklearn has sklearn.manifold Tisney. So with the documentation, you could get the information on how to implement it and information about it as well. How many components you're dealing with, and then transform your X and then try to get it. But well, for me, for this problem, I think it would rather be probably interesting. Instead of using Tisney per se, you could try to just do the classical traditional data feature engineering. I know random forest is able to kind of like give you a model and then give you which features are actually important with regards to giving you some percentage of their level of importance. So you could try that technique than using Tisney, because usually Tisney PCA are mostly for unsupervised learning problems where you try to reduce your data to lesser dimensions and all. But for this classical classification problem, it's maybe interesting to rather try the random forest where it would give you which features are actually more important. I think I did something similar like that and showed you. So you could rather like play around with those ones and then try to extract them. But of course, you could look at the Tisney just to like get to learn about it or something.
Okay, what you're saying here is I should, if I know how to do feature importance with random forest and others, I don't need to check.
Yeah, but
Tisney and
you
every
could
other thing. I don't need to
check
instruct them.
check this for your own knowledge, like just to know it, get to know it. But to solve the this particular problem, I'm not sure that Tisney would probably be like your go-to right go-to technique. But get to know it, do it, just read about it and try to get to know it. Yeah. Any other question? Yeah, I said I'll touch on decision trees. What exactly? I think the decision tree is just basically to try the model, which I just went over it a little bit in my notebook on how to build the decision tree and plot it. So I don't know exactly what you want me to do on decision tree. Is that you want me to explain how decision tree works or what exactly, Patrick? Sorry. Because I just use the decision tree here, importing it and then using it to build your model. So Patrick, could you come exactly what you want me to touch on in decision tree? Ah, okay, how it works. Okay, yeah. So I was just to use it in your, I mean, work with it with your data set, fit it, and then predict and see how to get your feature importance and plot to see how it looks like. Basically that. So, okay. All right. So, if there are no other questions, I guess this would be it then.
Okay, Deborah, I think do you have this week folder so that you can upload these materials there so that they can have access to it?
Okay.
Yeah.
All right. So I'll do that. I'll upload it there then, just in case you need it. Yeah. Thank you so much for having me, and yeah, we'll be in touch. You have specific questions? Oh yeah, you could email. You can send me an email. I think we're in touch on LinkedIn, so we can talk later. If they need be. Yeah. So if you're also interested in machine learning in finance, I've worked a bit on credit scoring, and currently I'm working on financial inclusion in Africa. So, I mean, I'm open to discussing with you all if you have something related to that, or maybe you want to talk about AIMS or AMI too. I'm also open to helping you. I think I put my name, my email, and LinkedIn in Slack, so you can get it later on, and then we can talk. Yeah. Okay, so that's it. So, Mustafa, I guess.
Yeah, so if you are done, I just stop the record.